Okay, question number 4. A solid block. This question is for 10 marks. So I have allotted the time to be around 10 marks. Let me start. Right. A solid block of glass is covered with water. The diagram shows the path of a monochromatic light ray entering the water from the glass block. Okay, it's given here. This is an incident ray, this is a refracted ray. This is glass, which means what is a refractive index? As we know, it is 1.5. For water, it is 1.33. Which means the ray is going from a denser medium to a rarer medium. Okay. The speed of light in glass is 2 into 10 power 8. So this is already given to you, which is Vg. And then calculate the speed of light in the water. We want to find out what is the speed of light in water. State an answer to an appropriate number of significant figures. Okay. Now how do we do this? Now whenever there is a problem on refraction, you can always apply Snell's law. So what does Snell's law tells you? It tells you that the refractive index of this medium. What is the refractive index of this? Let us say this is equal to some mu g and this is your mu water. Okay. So I can now write this as mu g sine 55 is equal to mu water sine 71. Okay, we have written this. Now we know mu g, I will write it here, yes, space here, right? Mu g is equal to C by Vg into sine 55 is equal to mu w is C by Vw sine 71. This C and this C goes away. You are now left out with this. What is that you need? Vw we need. So therefore, now what we can write is that we can now write what is Vg. Vg is already known to you. Let me write down the same formula once again. Sine 55 divided by 2 into 10 to the power of 8 is equal to sine 71 divided by Vw. Okay, which means Vw will be equal to sine 71, retaining this one, multiply this by 2 into 10 power 8, 2 into 10 power 8 divided by the sine 55 will come downwards. Sine 55 will come downwards. When you calculate this, I have already calculated this one here. Okay, so what I will do is I will first calculate these two together. When I do this, I get this as 1.15 multiplied by 2 into 10 to the power of 8. So if I take the product of this, this comes out to be around 2.31 into 10 to the power of 8 meter per second. Okay, at 2.3 you get over 2.30, 2.30 10 to the power of 8 meter per second. This is what is the final answer you get. Okay, next. Let us move on to the next question. So the marks allotted to here would be something like this. First is application of the Snell's law. The second will be 1 mark. Okay, by writing down that equation, this equation properly, and then substitution of this. Okay, and coming until here, you might get 1 more mark, and finally representing the final answer and that too with a given significant figures, you will get the 3rd mark. Right. Next. State and change. Explain the change in the wavelength of the light at the glass water boundary. At the glass water boundary, why there is a change in the wavelength? See, we know that whenever you are talking about waves, and the only equation that is helpful for you is nothing but V is equal to F lambda. Now, when a light ray goes from a denser medium to a rarer medium, or from a rarer medium to a denser medium, what will change? Velocity will change. If velocity changes, one of them should change over here. Which one will change? Frequency will always remain constant. I told you already, frequency never changes. And what change can change? Lambda should change. Okay. So therefore lambda should change. But this is for 2 marks. So how do I write it? First is light when it goes from glass to water, what changes? So refractive index changes. Refractive index changes when there is a difference in medium. First thing that you should write. Okay. And as a result of it, what happens? Velocity of light changes with change in refractive index. Maybe you could have written this one directly over here. Okay. So once this has been done, and after that, what happens? Therefore, since, or maybe you can write, since V equal to F lambda and V changes, F does not change. Very important to write here. Okay, F does not change and only lambda changes. This will give you definitely 2 marks. Okay. Now let us move on to the next one. The light ray is partly reflected from the glass water boundary. Draw on the diagram the path of the reflected ray identify the direction of polarization of the reflected ray. This particular path is not there in your syllabus. Okay. So anyway, we will start with this one here. So draw on the diagram the path of the reflected ray. What is the reflected ray here? How do I draw the reflected ray? Okay. So it says partially reflected. When you say reflected ray, that means it should definitely, the angle of incidence should be equal to angle of reflection. Where will the reflection happen? Will it happen like this? No, it will happen in the same medium. That's the definition of reflection, right? So therefore, reflection will happen like this, and this angle would be 55 degrees. So do not write anything over here. You should write over here so that this is 55 degrees, and thus you have to mention this. So this will fetch you 1 mark. Okay, done. Identify the direction of polarization of the reflected. I will do this also if you want. Okay, the polarization has been removed from your current syllabus in 2025. Okay, so therefore, so if you want this answer, this is nothing but it would be parallel to water glass interface. The reason is because when you say about a light ray, it will have both electric and magnetic vibrations. And when you say polarizing, then what can happen? The electric vibrations will become parallel to the interface. So therefore, this is the right answer. Okay. Then the water is removed and then replaced with air. And the refractive index of air is 1. Direction of the incident ray in the glass is unchanged. Determine whether the light emerges from the glass block into air. Now what's happening? Let us write down the figure once again. We have some space. So this is how it is. This was water earlier. Now I will write this as air over here. And this is glass over here. Glass over here. Ray of light is now coming like this. It is incident over here. This angle was seen to be 55 degrees. That's now we wrote this, right? 55 degrees. And now his question is whether that what could be the angle of refraction? If it is refraction, will it be refraction or not? That's the question. So how do we do it? Now first thing is, let us understand this is going from a denser medium to a rarer medium. When it goes from a denser to rarer medium, there are two possibilities. The first one is, if the angle of incidence is less than critical angle, then it will refract. There will be a refraction beam C. If it is greater than critical angle, then definitely there will be only a reflection being observed, which you call it as total internal reflection. If I is equal to C, what is C first of all? Critical angle, right? Critical angle, then in that case, the ray will graze along the separation, This is what you have learned, right? So therefore, now what we have is, you can see this in the same animation shown here, right? Okay. So now, so therefore, if this is the case, I less than C, now we need to find what is the critical angle. Only then we will be able to decide it. Now, how do I decide it? What is the formula for critical angle? The formula for critical angle is right here as mu glass into sine C is equal to 1, right? I do not know what's the value of C. So I will write sine C is equal to 1 by, okay, I'll write down value here. This mu glass, what is mu glass? Do we have the value of mu glass? No, we have not been given. We cannot assume something over here. So we'll just write C divided by Vg. C divided by Vg into sine C equal to 1 over here. What is C? C is nothing but 3 into 10 to the power of 8. What is Vg? 2 into 10 to the power of 8. This is given already, right? This goes away here. Into sine C is equal to 1. Or in other words, sine C, 3 by 2 sine C is equal to 1. Sine C is equal to 2 by 3. C is equal to sine inverse of 2 by 3. Now, what is the value of sine inverse of 2 by 3? I have already calculated this. You can see this in your calculator also. Sine inverse of 2 by 3 would be equal to 42 degrees. 42 degrees. Now, which condition will hold good here? See, this is 55 degrees. 55 degrees is greater than 42 degrees. So, what can happen? No refraction. No refraction, which means what? The rays of light will not go through this one, but instead there will be a reflection over here. Okay. So this is what you call as a TIR. Now what is that I need to write? Determine the light emerges from the glass block into the air. How many marks is this? For 3 marks. So the first mark would be for doing all this calculation and then showing that critical angle is equal to 42 degrees. Okay. This will be at least until here. This will be for 1 mark over here. And after this, what happens? You are showing that since 55 degrees greater than 42 degree, no refraction, and you are mentioning that there is a total internal reflection. Okay, this will carry 1 more mark. Okay, So therefore, and finally, okay, so this will be 2 marks, this would be 2 marks, this would be 2 marks, and this would be 1 mark only. Just 3 marks have been afforded. Okay. So with this, I think we have come to an end to this particular problem, and we have finished this in time. Let us see the next problem tomorrow. Thank you.